In the next video in the Learn Telos and EOSIO series. Today we're going to be continuing our deep dive into blockchain consensus using EOSIO. So guys, as we saw in the last video, blockchain consensus on Telos is broken down into two parts. You have the election of the top 21 block producers, and that's all done on-chain through the system contracts. The election, the voting, registration, and then you have the production of blocks themselves and the management of the blockchain. And that's done through the rest of the Node EOS software. So the Node EOS software is the node software that each node in the network runs. And that's done through several of the plugins. So last week we saw that we got to the block producer rankings on the Telos network. You can see here Telos Miami leading the block producers today, with Good Block coming in second. So now once we have the top 21 block producers, what happens? Well, they get put into a schedule. That schedule has 21 rounds, each round for each of the 21 block producers. And in each round, each block producer is assigned 12 slots to create 12 blocks, one in each slot. At the end of each round, the block producer hands over to the next round owner, so the next block producer who creates the next 12 blocks. And this creates a schedule of 12 times 21 blocks, 252 blocks. And that creates a complete schedule of 2.1 minutes. So in the Telos network, we have the top 21 block producers, and you have 15 of those are needed to come to consensus. The rule in the EOSIO protocol is that you need 2 out of 3 plus 1 block producers to achieve consensus. So in a 21 block producer network, that's 15 nodes. In a 1 producer network, so a centralized network, you would need 1 node to come to consensus. So in Telos, once blocks from 15 of the block producers have been created on top of a block, that's when it's considered final. That's when it's considered irreversible. And in Telos, you have 12 blocks per PB, like I just mentioned. So in the next few slides, we're going to consider an example EOSIO network. And the example is going to have only 4 BPs, so you need 3 out of 4 to finalize. And each BP only creates 2 blocks. So this is done just to create illustration purposes because my screen doesn't fit 21 block producers. It'll just be too confusing. So in our example network, we have four top BPs, so that we have Telos UK, Good Blocks, Telos Green, and Telos DAC have made the cut. They've been elected as the top 4 BPs. In our network, we also have several other BPs around the place who are going to play a role as well. So what happens is those top 4 BPs, as soon as they become elected to be in the top, they start creating a very tight mesh of network connections between them. And they create connections to 1 or 2 other nodes out of the network, 1 of the 2 other full nodes running the EOSIO software. And that then creates the network of computers around the world that makes up the Telos, our example EOSIO network. So what happens now is you have a user Alice with a transaction. They want to use a DApp. So they send a transaction out to the network. 1 of the nodes in the network receives it and starts propagating it around to nodes around them until that transaction is received by the nodes in the top 4. Another user equally sends their transaction out to 1 of the nodes in the network, which gets propagated until it gets to the top 4. So at this point, it's Telos UK's turn to create a block. They're the first one in the schedule. So they get those transactions and they put them into a block, right? So they order the transactions by the order that they received them, and they put them into them time chronologically. At this point, that block gets created. It links to all of the previous blocks. If you want to see how that happens, have a look at my other video. We're going to look at the block structures and transaction structures in more depth. So the transaction is created. It links to the previous blocks, and that's then sent around to the other block producers in the core network, and they then sync that out to the rest of the network outside the top 4. At this point, it's Telos UK's turn to create the next block in their round. They create it, send it out to the rest of the block producers, and this keeps going on until it's the next block producer's turn, which is good block. So they create the third block in the schedule, send it out to the other BPs, and this basically keeps going on. At this point, it's also important to note that these blocks continually get synchronized out to the rest of the network, to all of the other block producers that didn't make the top 4, and all of the other nodes that are running the EOSIO software connected to our example network. Now, once it's time to hand over to Telos Green, something important happens. At this point, three of the block producers have now built blocks on top of Telos UK's first block. And that means it's now considered to have come to a consensus. It's considered irreversible. And so is the second block that it created. Both of those 2 blocks now have 3 block producers. 3 is the 3 out of 4, or the 2 out of 3 plus 1 rule in the EOSIO consensus. So this process keeps happening. When the next producer creates the next block, that will then create an irreversible consensus block on the good blocks that they created. There you have it. So what actually happens during the production of a block? Well, the block producer receives transactions from nodes around the network. These transactions should already be pre-validated by other nodes in the network. So when you send a transaction to a node, it will check that it's going to fail or not straight away and send it back if it fails. This means that the top 21 block producers in the network rarely have to process transactions that would fail otherwise. And this frees them up with more time to process transactions that shouldn't fail. So now, once the current slot BP, once it's their turn, they create a block. They have to do that in half a second, 500 milliseconds. And they have 2 time frames within that. In the first 200 milliseconds, they have to create the block. And that means that they create the block structure. The first thing they do is they execute the on-block action, and then they execute all of the other actions all of the other transactions that they've received from the network. Then in the next 300 milliseconds, they sign the block and propagate it out to the rest of the top 21 BPs. After that, it's simple. They go on to the next block, or if it's not their turn anymore, they finish their round and hand over to the next BP. They may also have to check if the schedule is updated. So that on-block action is pretty important. It gets executed as the first action of every single block. And what it does is this, is every 1 minute in this action, it tallies up all of the votes, it selects the top 21 BPs, and it sorts those alphabetically and sets the schedule. That schedule then gets put in the block header so that everybody can see it. And this is what then changes the schedule. As people keep voting, this action here, executed as the first action of every block, will keep track of whether the top 21 BPs need to change. So the rest of the network receives the blocks created by the slot owner, by the block producer that creates it. So those nodes in the network can be the non-slot BP. They can be all of the standby BPs who haven't made it into the top 21, or full nodes in the network that are running the EOSIO software connected to the network for their own business purposes. So all they have to do is they have to execute all the transactions in the block as well, including the on-block action, and they update their EOSIO database as well. Then they just move on to the next block. So what's important to note here is that if any of the rules in the EOSI protocol are not met, for example, the data in the block is invalid, the transaction order is incorrect, they set the status of the transaction as failed and they shouldn't have, any of these things, if they don't happen, then the node will stop syncing the blockchain. And in this way, validators play an important role in the network. They're able to successfully block consensus attacks So just to further understand what's going in the network, we're going to have a look at a few common scenarios that do actually happen every day. So the consensus rules are basically The longest chain is the most valid chain, so nodes will try to find the longest valid chain with the most consensus. BPs are only allowed to produce one block at each slot, and they only get paid for blocks that are finalized, that come to the 15 out of 21 consensus. So we're going back to our 4-node network again. So under our normal operation, as we've just seen, block producers keep creating blocks that are linked to each other. And as a new block producer creates a block, once there is a 3 out of 4 block producer consensus, that means that the previous blocks become irreversible. So what can happen in this network? Well, sometimes the node software can fail and the block doesn't get created at all, or maybe it gets created without the right structure and stuff, so it doesn't get accepted by the other nodes. This is fine. The node will just move on to the next block straight away, and that will continue the network. Additionally, you can have what's called a microfork, which is where a block producer may get cut off from the network for a temporary period of time. So during this time, none of the other block producers will receive blocks that they create, even though they create them. This is easy to resolve. So as soon as the next block producer, it's their turn, they start creating blocks. They didn't see the blocks that didn't get propagated because of the network problem. And as soon as a majority of the block producers build on top of that other chain, that will then become the longest chain, and the rest of the network will sync up to it. Eventually, that will also achieve the irreversible consensus status. So it's important to note here that in both of these scenarios, which do happen in the network, these blocks that were never added to the blockchain were never paid for. So that means the BPs are really incentivized to try and optimize their network conditions and make sure their node software is running as optimal as possible so they can get paid for the blocks that they create. So finally, you can have scenarios where multiple parts of the network go down. It's very similar to the last scenario. As soon as those networks come back online, or as soon as other block producers start building it that can be connected to, a majority exists, and the longest chain rule resolves the chain. So guys, this has just been a draft preview video. This is part of a much bigger, high-quality free video series that explains Telos and EOSIO. So I'm planning on creating this video series. It's going to teach everyone from the basics, deep diving into Telos and EOS, as well as a developer series to understand how to build on top of Telos and EOSIO blockchains. We're also going to be building a beautiful landing page on the EOS Authority website to make sure people are aware of how to find this information, have it structured so you guys can learn this easily. And what's really cool about this work is it's a proposal on the Telos blockchain. It's an immutable proposal done through the Telos worker proposal system. That's a DApp on the Telos network that allows anybody with Telos to vote on this proposal to create this work. So if you want me to create this video series to teach you guys how Telos and EOSIO really works under the hood, and you like this video, then please consider voting for this proposal with your Telos, and you can check out more information at this URL here. So thanks guys, and have a good day.